Welcome to Algebra 2, Semester 1, Unit 3, Section 5.1. First thing here that we have is a table for the different properties. We just need a definition for each property. Product of powers. Let me just show you an example of this. Algebraically, it would be a to the m, there's our product, times a to the n equals a to the m plus n. So if we think about this, let's say that we have 5 to the, let's say third, times 5 to the second. If we were to expand that, that would be 3 5s times 2 5s. So it should make sense that it's 5 to the fifth, which is simply 3 plus 2. Okay. Next one is the power of a power. So we have a to the m raised to the n. That would be a to the m times n. And on these, I require you to expand them and show it. Here's an example of it. 5 to the third raised to the second would be 5 to the third times 5 to the third, which if we look up above, that would be 3 5s and 3 5s again. So it is 5 to the 3 times 2, which is 5 to the sixth. Next one, power of a product. If we have a times b raised to the m, then it's equal to a to the m, b to the m. Okay, so in other words, if we have 5 times 2 raised to the second, well, that would be 10 to the second, which is 100, which is the same thing as 5 squared times 2 squared. 5 squared is 25, 2 squared is 4. 4 times 25 is 100. Okay. Negative exponents. These are super important to know. If you have a negative exponent, the way to make that a positive exponent, which is very needed in order to go forward with the equation, you need to flip it to the other side of the fraction. You've got to get its reciprocal, and then the exponent becomes positive. Okay, so an example would be 5 to the negative second is equal to 1 over 5 squared, which is 1 over 25. You would never know going from there to there, so you need to show me the preliminary step there. Zero exponent, this just simply says that anything to the 0th power is equal to 1. Okay, now a favorite thing in standardized testing is to do this kind of a thing. Let's say we have 3x to the 0 plus 2x to the 0. You might say, well, that's 5x to the 0, but it's important that you realize that you can go further than that, because anything to the 0th power is 1, so that really equals 5, because that is equal to 1. Okay. Quotients. Should make sense that if we have a quotient, just like up here how we had the product we added, with the quotient, we're going to subtract. So if we have 5 to the third over 5 to the second, should be reasonable when you expand that out to see that it's 5 times 5 times 5 over 5 times 5. We reduce our like terms and we end up with 5 to the first, which is the same thing as 5 to the third minus 2. Okay? The power of a quotient, a to the m over b to the m is the same thing as a over b to the m. Okay? So, for example, 5 over 2 squared is the same thing as 5 squared over 2 squared, which would equal 25 over 4. Okay? Let's go down and do a few of these. Now, if I show expansion, then I expect you to show expansion in your work tomorrow in the book. So, we have negative 4 times 2 to the 5th. I would like you to go ahead and take negative 4 times 2 to the 5th. If we work that out, that's 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 2 is 4. And then we have 8 times 2 left over. This is 16 times 2, so that's 32. Okay? Now we want to square that. 32 times negative 4 is 128 negative 128 squared. Now the only thing that I'll ask you to do, I won't ask you to go ahead and multiply the 128 squared out, but I do want you to realize that a negative times a negative is a positive. So I would expect you to come out one step further and go 128 squared. And remove that positive. Okay? Negative 8 times negative 8 cubed, we'll realize that's a 1 on that one. So we literally have negative 8 times negative 8 times negative 8 times negative 8. Okay? That would make 4 8s. And if we have an even exponent, then the negatives cancel. Because a negative times a negative is a positive, times a negative is negative, times a negative is positive. Anytime it's an even number, cancels the negative out in front. Okay, next one. We would take this negative and distribute it in, just like we saw in the power of a quotient rule, that a over b to the m is am over bm. So we take negative 1 times 5 would be 11 to the negative 5th over 11, almost got ahead of myself, to the negative 8. Now, we don't leave negative exponents. Going back up to the negative exponent rule, we see that we need to flip a negative exponent to the opposite side to make it positive. So now we have 11 to the 8th over 11 to the 5th. Now if we were to expand that out, that would be 8 11s up on top, and it's 5 11s on the bottom. We reduce our like terms, and we see that we're left with 3 11s up on the top, so that can be written as 11 to the 3rd. I do not want to see you just showing this as a subtraction. Expand them out. Okay. 2 over 9. Don't be upset or discombobulated because it's a fraction. 2 over 9 and 2 over 9. That's what that says, is that there's 3 of those because of the 3 right there. So now we just multiply. 2 times 2 times 2 is 8. 9 times 9 is 81. Times 9 is 729. Okay? Next one. I want to see you expand this one out. 4 squared times 4 squared times 4 squared. And now you count them up. There would be 2 there. That would make 4. That would make 6. So that is 4 to the 6th. Next one. It's got a negative. We bring this in. So we have 1 to the negative 8th. We have 3 to the negative 4th. We have to flip them because they're both negative. So we have 3 to the 4th over 1 to the 8th. 1 to the 8th is 1. And 3 to the 4th would be 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So this equals 81. Okay. Last page of this unit. In scientific notation, we can have a negative exponent. Okay. To simplify this, right, 6 over 9, and then I go ahead and bring my exponents here. 10 to the negative 4th needs to go to the bottom. So we'd only have a 1 left on top, and we have 10 to the 4th times 10 to the 7th. Okay, 6 over 9, if we divide that out, is 0.666. It just keeps going on forever. And this would become 4 there and 7 there, 1 over 10 to the 11th. Now, in scientific notation, your first number has to have 1 decimal place to the right of the decimal. So if we adjust that, we would move the decimal to there. I want to show you which way we moved the decimal. So we moved it 1 to the right. Now, we cannot have this as a fraction, so we need to bring that back up as a negative 11. Okay, now we need to adjust because we moved this over 1 to the right. I had a student explain this to me one time. He said it's like writing on a bongo board. Look up bongo board if you've never ridden on one. Basically what happens is as you put this foot down, it lowers this, and it's going to raise that. And he said it's the same thing when you're adjusting scientific notation. And trust me, he got him right every time. So he said when he moves that to the right one, because we know in math to the right is a positive, he said make that a +1, and at the same time make this a -1, because you have to keep it balanced. So this now becomes 6.666 times 10 to the negative 12th. Okay? Next one. More scientific notation. We bring the numbers together to multiply. 4.2 times 1.5. And now we, by commutative property, move these 10 to the 6th and 10 to the 3rd together. Okay. Now let's multiply out that we have 4.2 times 1.5. We have 10, 21, 0, 2, 1, 330, 2 decimal places. We have 3.3 times 10. If we expand these out, there would be 3 tens and 6 tens. That would make 9 tens. Looks like my battery's running low. We're going to hurry these through as quickly as we can. So here we have b to the 6th, b to the 7th, But the b to the negative fourth needs to go on the bottom, so it's b to the fourth down here. Now if we expand that out, we would have 4 b's on the bottom that would reduce with b's on the top. I'm just going to write the 6 b's there. Those would reduce and would only have b squared left out of that bunch. And so we have b squared times b to the 7th. If we add those up, we get b to the 9th. Okay. On this one, it's a negative exponent. So we multiply it in. It's r times negative 3 times negative 2 is positive 6. M to the 3 times negative 3 is negative 9. So that negative needs to come to the top. So we get r to the 6th, m to the 9th as our final answer. Okay. Next one, we have n to the negative 5th, n to the negative 5th. Normally we'd switch them around, but since they're identical, we can reduce right there. 2 goes into 16 8 times, so we get 8 m to the 4th. Okay. Here we have a negative that needs to go to the bottom. Everything else can stay on top, so we have p to the 5th, p to the 6th, over p to the 8th. Okay. If we expand that out, we would have 11 p's up on the top and 8 p's on the bottom. If we reduce that, it would be 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8. We reduce, 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 reduce. We have p to the 3rd left. Okay. Okay, here we multiply this in. That c has a 1, so it becomes c to the negative 2nd, d to the 8th. That means we need to move that negative exponent down, so it becomes 1 over c squared d to the 8th. Okay. This one, we have a to the negative 3rd needs to be moved down, so we have b squared over a to the 3rd, a to the 5th. That would make it b squared over a to the 8th. Last one. We multiply the 2 in, so we get x to the negative 6, y to the positive 6, over x to the 5th, y to the 6th. The y's to the 6th are identical, so they can be reduced. X to the negative 6th needs to be moved to the bottom, so it becomes 1 over x to the 6th, x to the 5th. Go back through and watch this and pause the video and be ready to do problems tomorrow in class with me. Thank you very much.